Well, thank you very much for that introduction, Mary Lasky. Again, my name is Tom Popik. I'm chairman of the Foundation for Resilient Societies, and I will be giving a presentation this morning. If you could bring up the presentation, please, on a topic which is currently in the news, which is the threat from North Korea. My colleague, Jordan Kearns, helped out ably on the presentation, and so he's going to be available on call. But I'm basically going to go through the different elements of the presentation. Are we having trouble bringing it up? I do have one of those infernal sticks. It is. It's the first one, not the EMP cost one. Okay, very good. So what I'm going to do is I'm going to talk to the first couple slides while they bring this up. But I'm here to talk about the North Korea electromagnetic pulse threat. And let's look at the statements of the North Korean regime. We have their Communist Party chair explicitly saying that an EMP capability is a strategic goal of their regime. We also have other senior officials in the North Korean regime threatening an atmospheric test. We also have threats of a nuclear detonation in the area surrounding Guam. So, okay, here's my presentation. Thank you very much. So, the title is High Consequence Scenarios for North Korean Atmospheric Tests. I'm going to see if I can get there we go. So we're going to talk about the North Korean electromagnetic pulse threat. I've referred to some of these statements by the regime already. And I would just say to the audience, for North Korea, EMP is an asymmetric threat. What we have here is a 2014 satellite picture of the Korean Peninsula. You can see South Korea down there towards the bottom. You can see China up towards the top of the picture, and you can see that largely dark area, which is North Korea. So we're very dependent here in the U.S. on our electric grid. North Korea, much less so. If we were to have an EMP burst over our continent, I think the effects would be quite dramatic. For the North Koreans, less so. Well, the North Koreans have made this statement that EMP is a capability that's a strategic goal. They've also threatened an atmospheric test. We did a thought experiment. If the North Koreans were to do an atmospheric test, where could they do it? In the past, nations have used their own territory for atmospheric tests. The North Koreans have a problem. They don't have that much territory. What we've shown here is the North Korean land mass, but also their flight information zone. That's the purple line with the yellow around it. There's not a lot of room there. We put a green circle there, which is a potential atmospheric test site in the Sea of Japan. That altitude for line of sight for the green circle is only 1 kilometer altitude. At 1 kilometer, there would be debris picked up from the ocean. There would be fallout. It's really not a practical test site for an EMP test or any kind of atmospheric test. If the altitude were brought up to 40 kilometers, which is the start of the region for high altitude EMP for the E1 pulse, it would extend to the dashed line that you see at the edges of this graphic. You can see that the dashed line includes large parts of Japan, South Korea, Russia, and China. So it's really not practical for there to be any kind of an EMP test in the region of North Korea. Well, what else could the North Koreans do? Here we have the missile trajectories from their most recent tests, excluding the one that just happened earlier this week. The tests really fall into 3 categories. The first is lofted tests that descend into the Sea of Japan between North Korea and Japan. Then we have some more shallow trajectories They extend over into the northern Pacific. And then there have been 2 satellite launches to the south, and that's the white line going southward. So we're using these previous tests as a reference point. And now what I'm going to do is I'm going to delve into some technical detail just very briefly on calibrating EMP tests. And I'll go into some graphs here, and then we'll get to the really interesting part. So what are the 3 basic types of high-altitude electromagnetic pulse? Well, it's the E1 or early time pulse that damages sensitive electronics, the intermediate time or E2 pulse, which is very similar to lightning. Most critical infrastructure is already shielded against lightning. And then the E3 or late time pulse, which principally affects long conductors. What kind of long conductors are present in infrastructure? Basically 2 categories, long electric transmission lines, and also, importantly, long telecommunication cables, and especially undersea telecommunication cables. And I'm going to get into more detail about that in just a moment. This graph here shows that there are a wide range of altitudes and device yields that can be used to produce the E1 effect. On the y-axis, we have the height of the burst starting at 0 and going up to 400 kilometers. And on the x-axis, we have the field effect on the ground going up to almost 100,000 volts per meter. You can see that the lines are also distinguished by the device yields. We do have a line for 300 kilotons, which is approximately the yield of the last underground test conducted by North Korea. Bottom line here is that the E1 effect starts at approximately 40 kilometers and extends up at least to 400 kilometers. There's also 2 parts to the E3 effect. This is the E3A field. You can see that that field peaks out around 400 kilometers and then descends. It also depends on the density of the atmosphere. There's a E3B field that maximizes around 140 kilometers. Big takeaways here. There's a wide range of altitudes for the E1 effect. It is impossible to optimize both elements of the E3 effect with just one altitude. What we did now is we used this technical information, which is open source information. And I say at this point that we were meticulous about this. We used only open source. And then we have a white paper which we've just released yesterday. And that white paper did clear classification review. So again, we were meticulous in our research and in using only open source material. So now I'm going to transition from the details of electromagnetic pulse effects to some of the potential impacts on critical infrastructure. Miniaturized electronics are vulnerable to the E1 pulse. I'm sure that's familiar to many people in the room. A lot of people don't understand that submarine cables, undersea submarine cables, are very vulnerable to the E3 pulses. Let me explain why this is so. The cables themselves transmit information on fiber optics. Fiber optics don't conduct any kind of electromagnetic pulse. However, there are repeaters that are necessary approximately every 100 kilometers along the path of the undersea cable. These repeaters are essentially amplifiers, and amplifiers require a power source. They require electricity. So there are direct current power leads that extend the entire length of the cable. These power leads are long conductors, and they will in fact pick up the E3 pulse from a high altitude nuclear detonation. Also, I would point out that the landing stations, which are on ground, will be vulnerable because they have a lot of electronics to the E1 pulse. We know that power grid transformers are vulnerable to both the E1 and the E3 pulses. And then finally, people don't often think of this, but satellites are vulnerable to high altitude nuclear detonations. There's a couple effects. First of all, the immediate effect from X-rays within the line of sight, and then also the high altitude detonations release free electrons, and those free electrons linger in the upper atmosphere, and when they collide with the sensitive electronics in satellites, it causes early failures. These failures can occur over a period of months, and a large percentage of the satellites in orbit after the 1962 Starfish Prime test did in fact fail. But modern societies are now vastly more dependent on satellites for a whole host of things. It's mostly the satellites in low Earth orbit that would be affected by an EMP burst. Now I'm going to get to what I think is the most interesting part of today's presentation. We did put together potential scenarios for North Korean atmospheric nuclear tests. We came up with 5 scenarios. 2 of the scenarios are non-EMP scenarios. These are just atmospheric tests, and 3 of the scenarios are EMP scenarios. We again considered the past missile launch trajectories in developing these scenarios. We considered the required height of burst to achieve EMP effects. We considered certain geographic factors and missile range factors. And then, frankly, there's some psychological factors that are parts of these scenarios as well. Here's scenario 1. We call it the North Pacific scenario. This launch trajectory follows some of the previous trajectories that the North Koreans have used. It terminates in the Northern Pacific. If you look at the yellow circle, that is the diameter on the Earth for a 20-kilometer altitude burst. Also, you can see some pink lines in this graphic. The pink lines are the locations of submarine cables. Now, for a 20-kilometer altitude burst, there would be no EMP effects, but we wish to introduce early on in the scenarios that we were able to get maps of the locations of these cables. I should also say that 98% of the international trade is enabled by financial transactions that are carried over these undersea cables. So if there is an EMP test and these submarine cables are taken out, we're really talking about potentially worldwide economic impact. This is our second scenario. It's also a non-EMP scenario. You can see the trajectory starts out from North Korea, extends south along the previous trajectory of a satellite launch, and descends into the Philippine Sea just east of the Philippine Islands. Again, this is a 20-kilometer burst height. It so-called threads the needle. This trajectory doesn't overfly land masses. Why is that important? Because it's very rare that nations have tested a nuclear device mated to a missile. In the past, tests have been conducted by airplane drops, by warheads that are lofted from barges, but to actually test a nuclear device mated to an intercontinental ballistic missile is very rare. Why is this? It's because there's the potential for navigation and fusing errors. So for example, in this particular trajectory, if there's a navigation error, that burst could actually occur in the Philippines. It could produce widespread plutonium contamination in the Philippines, and if there's a navigation and a fusing error, there's the potential for even more dramatic consequences. So now what I'm going to do is get into the electromagnetic pulse scenarios. This is scenario 3 for the South Pacific. You can see the trajectory starts from North Korea and extends into a largely unpopulated area of the South Pacific. The burst height in this scenario is 400 kilometers. There would be significant both E1 and E3 effects. However, populated areas would be largely spared. There's a population in French Polynesia, which is at the edge of the line of sight, and then there's just that one submarine cable going down to French Polynesia. So what we would call this is a minimal infrastructure impact test. It could have tremendous instrumentation value. One of the things that we're recommending is that the US government monitor very carefully any attempts by North Korea to instrument an atmospheric test, especially instrument those atmospheric tests for EMP effects. I'll now go to scenario number 4 for Johnson Island. This has symbolic significance because Johnson Island was the location of the last EMP test conducted by the United States, Starfish Prime, in 1962. That was at a 400-kilometer altitude. This particular scenario is only at 150 kilometers. Nonetheless, the Hawaiian Islands would be at the edge of the line of sight. There would also be a number of submarine cables that would be underneath the line of sight for this particular scenario. So we think that this scenario has both symbolic significance, but it could also have significant impact on critical infrastructure. Our last scenario is the Guam Scenario. Why is this so important? It's because the North Korean regime has specifically threatened the island of Guam with a detonation between 30 and 40 kilometers from the island. So we chose a distance of 35 kilometers north. We have two burst altitudes, a 40-kilometer burst altitude, which would cause only E1 effects, and a 150-kilometer burst altitude, which would cause both E1 and E3 effects. You can also see, if you look at the pink lines here, that Guam is a hub for undersea telecommunication lines in the Pacific. There's all sorts of these cables around. If you go just to the east, you can see these masses of cables that connect various Asian trading partners. When you look at the scenarios, especially this last scenario, you start to understand that a North Korean atmospheric test, especially of EMP capability, could have tremendous infrastructure impacts. And these infrastructure impacts would extend into Asian nations, their trading partners. It could really have a worldwide impact. So now I'm going to move to just two more slides, conclusions. There are no low-risk options for the North Koreans to conduct atmospheric tests, including EMP tests. There could be errors in navigation or fuse operation. Aircraft near the blast, of course, might be affected, and the North Koreans have not been giving notice to mariners nor notice to airmen in advance of tests. EMP tests near Hawaii or Guam are likely to have very significant impacts on critical infrastructure. Regardless of the location, there is the potential for debilitation of undersea cables and or satellites. Nuclear tests, the last point should be obvious, nuclear tests near US territories could be considered acts of war. So I'll finish up here with some policy recommendations for the U.S. government. We did this research not as an academic exercise. We really want the U.S. government to do something differently if it has not already taken appropriate proactive measures. First of all, there's diplomatic actions that should be taken. North Korea should be warned that there are no low risk or low impact options, and this kind of testing should be discouraged before it ever occurs. The trading nations in the Pacific should be alerted that there are some scenarios that could disrupt undersea cable traffic and disrupt international trade. This is especially important for China, which is dependent on food and energy imports. The U.S. government needs to instrument the Pacific region for EMP tests. In our working paper, which has just been recently released, we have a dozen locations that we suggest for both E1 and E3 instrumentation. The last atmospheric test the United States conducted for EMP was in 1962, and the instrumentation during that test went off scale. So it wasn't completely instrumented. If there is another atmospheric test, the United States cannot lose the opportunity to acquire more data on this very important phenomena, certain aspects of which need to be better understood. Any attempts by North Korea to set up instrumentation should be very, very carefully monitored. They may be tip-offs. For example, in that South Pacific scenario, if there's North Korean vessels which are sailing in a circle in the South Pacific, that could be a tip-off that something may be happening. And finally, we say the United States and its allies, and maybe even quasi-allies, such as China, should be prepared to take what we call anticipatory self-defense actions. So that's our presentation. We really appreciate your attention. I've been informed I need to finish up. Mary, how are we doing here?
We're doing fine.
Okay, great.
So thank you so much, Tom.
You bet. Thank you.